Hi, I am Amit Lunkad. In this video, we discuss about the structural activity relationship of prostaglandins. As all of you know, prostaglandins are powerful locally acting vasodilator and it also inhibit aggregation of blood platelets and which involve in inflammation reactions. In this video, we discuss in detail about the structural activity relationship of prostaglandins. Let's begin with this structural activity relationship of prostaglandins. And here is the structure of prostaglandin. So prostaglandins are unsaturated carboxylic acids consisting of 20 carbon skeleton that also contains a 5-member ring and are based upon the fatty acid arachidonic acid. Means these prostaglandins are synthesized from arachidonic acid. For discussion of structural activity relationship of prostaglandins, we divide the structure into three. First one is upper chain, then second one is the cyclopentane ring, and third one is a lower chain. So we made the modification to this and see the what happens on this modification. So first modification in the upper chain. Methyl ester, sulfonamide and hydroxyl group possess greater activity than natural prostaglandins. Here it having prostaglandins having a carboxylic acid. But if we made the changes modification to this, then it will give the greater activity. Like if there are the presence of methyl ester, then it will have a good activity. An example of compound is misoprostol. Second one is that if there are the presence of sulfonamide, then example of compound is sulprostone and which also having a good activity. And third one, if we have a presence of a hydroxyl group, example of compound is rioprostil and it also possesses a very good activity than the natural prostaglandins. So this is the first point for the modification in upper chain. Moving to the second one, the modification or changes if we made to this cyclopentane ring. Variation in cyclopentane ring leads to reduction in prostaglandin activity. Even enlargement of ring or reduction of ring size leads to inactive compound. If you replace the carbon atom of cyclopentane ring by oxygen, sulfur or by nitrogen, it leads to formation of a inactive compound. But if you replace the 9 keto group here, the 9 keto group with presence of double bond CH2 group, it gives a active prostaglandin. Example like metenprost, which having a instead of 9 keto, it having a double bond CH2. Now modification to the lower chain. The 15 hydroxyl group has been protected from metabolism by introduction of a methyl group at carbon 15 and geminal dimethyl group at carbon 16. So we made this modification so to protect it from metabolism. Next one is the shifting of 15 hydroxyl group to 16 position. It can also give the metabolic stability. That is, it increases the metabolic stability. And if there are the presence of alkoxy and phenoxy analog which have a more activity than natural prostaglandins. Example like N-prostil and sulprostone. Just we have seen in case of upper chain modification, example of sulprostone, and in that there are the presence of a phenoxy group. So which are more active than natural prostaglandin. Next one is the introduction of a acetylenic group at carbon number 13 and carbon number 14 which increases the luteolytic activity. So here about this structural activity relationship of prostaglandin. Hope all of you getting this. Thank you and happy learning.